Tesla's new battery, which was announced at the company's Battery Day event last year, offers a slew of new features in a single upgrade. You're not going to believe how Tesla battery developers got rid of the tabs that connected the cathode and anode layers to the positive and negative terminals, while still increasing the physical size of the battery cells from 2170 to 4680. In this video, we will tell you how the Tesla 4680 battery will be the last solid-state battery. Without further ado, let's get right into it. Elon Musk has stunned the world with his future vision and ideas for the past decade, from launching rockets into space to proposing underground train transportation systems and Hyperloop. He's a visionary who has shifted our perspective on technology and sparked hope for the future. He has yet to conquer one obstacle, and that impediment is none other than batteries. And it is these issues that are preventing MOUs from taking Tesla automobiles to the next level. However, he recently announced that Tesla is developing a new 4680 battery to transform the electric vehicle business. Electric vehicle industry. When it comes to production, Tesla has a unique position in the electric vehicle business. Tesla, the auto industry's most vertically integrated firm, can make any aspect of its automobiles or production process more economical and efficient. Tesla has achieved this with its new breakthrough tabless batteries, used in future electric vehicles. The lithium-ion batteries that power most of today's consumer devices were first developed by British chemists in the 1970s, and Tesla's new 4680 battery are based on them. Yoshino created the first lithium-ion battery prototype that worked. In 1991, Sony scientists developed the first commercial effective lithium-ion battery. So, what makes this lithium-ion battery unique is that it outperforms every other sort of battery previously used. For example, the earliest rechargeable lead-acid batteries, created in 1859, are 10 times larger than lithium-ion batteries, need 3 times longer charging periods, and have a 5-fold lower power density. It's no surprise that lithium-ion batteries swept the globe in an instant. Yet, despite being far superior to any other form of battery previously utilized, lithium-ion batteries still have flaws and lag behind practically every other electronic component. Our technology isn't progressing as quickly as it could because of the batteries. Tabless battery for Tesla. So the question is, what was the purpose of Tesla's tabletop battery? Last September 2020, at Tesla's Battery Day event, the company unveiled a new tabletop battery. Tesla's project was not purely academic, it was motivated by a specific need. Tesla has been purchasing batteries from sources that employed proprietary chemists and architectures, as had other battery makers. This worked well for Tesla, until Elon Musk realized that the company's battery supply chain would present issues in the future. Scientists and engineers have yet to discover a method of storing more energy in a smaller space. Elon Musk, on the other hand, has lately given some specifics about his upcoming 4680. This might trigger a second battery revolution, radically altering our planet. Every year since 2013, Tesla has held a Battery Day event at which they announce their most recent advancements in the field of batteries. Tesla's 4680 battery, the revolution. For Tesla fans, it's one of the most important days because they know that batteries are holding them back. Tesla's new 4680 battery format was unveiled by Elon Musk, who complimented it for its revolutionary qualities. It differs from the Panasonic 2170 lithium cobalt acid battery, not only in terms of attributes, but also in terms of the battery's structure. Amazing, right? This means it shortens the electrical route, lowering resistance and heat generation. Furthermore, rejecting the previous designs with tabs makes these batteries easier to manufacture currently. Instead of having numerous tabs, which used to cause manufacturing issues, it's essentially a one-piece battery. Unlike earlier Tesla batteries, the new Tesla 4680 battery will not include cobalt. Cobalt is an excellent component for batteries, but it has one drawback: it is harmful to people. High nickel cathodes were used instead of cobalt, resulting in even superior performance. Tesla was able to squeeze more into less space as a result of all of these changes. In comparison, only 960 new 4680 cells would be required to complete the same task. The fewer individual parts a car needs, the easier and less expensive it is to produce. Now that we've learned about the future trend of battery design, we need to consider how it will affect consumers. It will be 6 times more potent than its predecessors. For starters, 5 times the amount of energy. The new 4680 battery cell is double the size of the present 2170, but it will be far more efficient and provide a significantly greater range per battery space. Finally, because of its tablet design, charging times will be lightning fast. The new Tesla Model 3 with the 4680 battery pack is expected to take just 15 minutes to charge from 10% to 80% instead of the current 25 minutes. It currently assumes you're going to change the new battery pack from 0 to 50% charged. It will only take 7 minutes, which is almost as long as a tank of gas. The new 4680 battery is superior in nearly every manner, but it is also predicted to be half the price of present batteries. It will not only be simpler to construct, but it will also use 30 to 40% less steel, which is one of the most costly components in the process. The new batteries are also less harmful to the environment than their predecessors. It uses less water and is less detrimental to the environment, making Tesla EVs even more environmentally friendly than they already are. It's intended to be used in the upcoming Tesla Model 3, which will debut in 2022. The Tesla Semi, a new generation truck, is delayed for 3 years but will debut in 2022. However, it's crucial to note that while Tesla's new 4680 battery prototypes are functional, the job isn't yet finished. So far, significant progress has been accomplished. Internal crash testing of our structural pack architecture with a single-piece front casting has been successful. They will have a lot of work to do before we can start producing in larger quantities. Tesla is no stranger to manufacturing delays, as we all know. Almost every Tesla vehicle has been delayed, which has fans enraged. The manufacturing. Elon Musk has been working on it for nearly a decade, attempting to figure out how to make the production process go faster. The Gigafactory in Berlin, announced in 2019 and set to open in the summer of 2021, exemplifies this. Unfortunately, it has been delayed, and its release date has been moved back to the end of 2020. The factory will be able to manufacture up to 100 gigawatt-hours of battery capacity each year. Assurance that Tesla will be able to meet the massive demands for new models, Tesla hopes to have several more by 2030. Gigafactories are building their new 4680 batteries and can produce up to 3 terawatt-hours of battery per year, solidifying their position as the world's leading EV manufacturer. We'll be able to see if Elon Musk can keep his promise, but if he can, it will transform the electric car industry. Any mention of production difficulties at Tesla conjures up memories of the Model 3's rocky launch in 2017 and 2018, during which Musk slept at his office. Despite this, Tesla became the world leader in electric vehicles and one of the world's most valuable firms due to that pivotal car. The enlarged cylindrical 4680 batteries come with its own set of high hopes and challenges. If Tesla can pull off in-house, vertically integrated battery manufacturing and the cell performs as advertised, the 4680 could help Musk realize his vision of mass-producing millions of electric vehicles per year worldwide. Tesla's objectives include increasing driving range of more than 50% to 16% thanks to the 4680's increased power, halving battery prices, and bringing a $25,000 Tesla to showrooms. In the United States, Tesla is the market leader in electric vehicle sales, but its seemingly impossible advantage in driving range is being questioned. The Lucid Air sedan, manufactured in Arizona by Musk's former Model S chief engineer, has proven to drive up to 517 miles, a world record for any electric vehicle. According to the EPA, the Model S long range, Tesla's most significant car, has a range of 405 miles. To go back in front, a 50% range increase for a vehicle like the Model S would allow it to travel 600 miles. A diesel-like range that was unthinkable just a few years ago. So much for range anxiety. The last solid-state battery. During Tesla's Battery Day in September 2020, the 4680 battery, a cylindrical battery with a diameter of 46 mm and a height of 80 mm, was presented. The 4680 battery, according to Tesla, will have 5 times the capacity, 16% more driving range, and 14% lower prices than the 2170 battery. Currently, prismatic batteries are primarily used by domestic automobile manufacturers. Only Tesla, Daimler, Nissan, Renault, Volkswagen, and Hyundai use cylindrical pouch power batteries on a larger scale. Car manufacturers, on the other hand, take time to update their battery types. Based on the rate at which the 2170 battery replaces the 18650 battery, and assuming the 2170 battery remains the mainstream battery in 2022, the 4680 battery will gradually replace the 2170 battery by 2023 and completely replace the 18650 battery by 2024. The battery capacity is improved due to the usage of high-nickel ternary cathode materials. The 4680 battery has 5 times the capacity of the 2170 battery, not an increase in energy density of 5 times. Thus, the increased battery capacity will result in a 16% increase in driving range. The tablet structure allows thermal runaway to be effectively controlled. The advantages of cylindrical battery cells in terms of heat dissipation are that the capacity of a single unit is low, and the heat release of a single electrical runaway is not easy to spread. Moreover, the arc-shaped surface suppresses heat transfer between the batteries to some extent. This is indeed a breakthrough. There are fewer battery cells and a greater rate of space utilization. The cost savings are primarily because of the 2170 cylindrical battery power requires 440 cells, whereas the 4680 battery only requires 950 cells, resulting in increased space utilization and assembly efficiency. In addition, as compared to the 2170 battery, the 4680 battery uses fewer non-energy dense raw materials, such as battery separators and steel shells, lowering prices. Wow! Tesla definitely set the A standard of producing quality batteries. Have you ever thought of utilizing these batteries? What are your reactions to this video? Also, what are your thoughts? Feel free to drop your reviews and responses in the comments section below. And before leaving, don't forget to like, subscribe, and hit the bell button for notifications on our future content. See you in the next video.